We've got a trig one for c. We've got 0 and pi over 2 of sine x times by the square root of 3 cos x plus 1. So u is equal to just cos x, is it? Often I do the bit in the whole bracket there, but let's work with that. U equals cos x, so that differentiates. Cos differentiates to give minus sine. That's going to nicely cancel that there, isn't it? And so dx is du over minus sine x. And we've got x numbers of 0 and pi over 2. So that gives u numbers. The cos of 0, of course, is 1. And the cos of pi over 2, is 0. So that's interesting. So it's the first time that's happened, isn't it? That actually the lower number here is the 1 and the upper number here is the 0. You might not have seen that before. So I've got the sine x here. Here I've got the square root of 3u add 1. And the dx is the du over minus sine x. And so the sine x's can cancel. And so we've got minus the integral from 1 to 0 of 3u plus 1 to the power of a half du. So interestingly, now we've got that minus there, it's actually going to flip these bounds round again. But what does this integrate to give? Well, the bracket is staying the same, but its power's going up by 1. So we've got 2/3 here. We've also got to divide by that 3 as well. So I've got minus 2/9 of that. And that's between 0 and 1 there. Putting the 0 in all of that, that's just going to be minus 2/9, isn't it? And putting the 1 into all of that, so we've got 4, square rooted is 2, cubed is 8, so I've got 16, so minus 16 over 9 there. So my final answer, I've got 14 over 9.